Hello and welcome back on Root Access Berlin. We are again recording here from the factory studio in Berlin, and today I have with me Jérôme Mouton, the CTO of SnapEngage. Hello, Jérôme.
Hello, Martin.
Can you please introduce yourself?
Yes, absolutely. So I'm Jérôme Mouton, I'm the CTO and co-founder at SnapEngage. We're a small company providing software as a service on the Google Cloud platform. Our customers are using SnapEngage to engage their visitors on their website and to assist them through a sales cycle or for customer service.
So let's see a demo. Let's see what this looks like. Here we have the website of one of your customers, and I have opened this little live chat widget.
Mm-hmm.
That one is provided by SnapEngage.
Exactly. So these customers added the SnapEngage JavaScript client on their website. And when you clicked on the little button to open the chat, this window popped up and provide you the option to leave a message or to chat with this customer.
And so today we are going to answer a question. There is a recurring question on App Engine. How much does it cost? Every time I talk about App Engine with someone, that's a question that comes again because it's not so easy to determine how much you are going to pay for your application. In App Engine, everything is metered and you pay according to your bandwidth usage, CPU usage, and so on. However, here with SnapEngage, we have an application that has a significant traffic. And so Jérôme is going to tell us about the associated costs and how to optimize them. So first of all, Jérôme, how much traffic are we talking about?
On a month, on average, we serve a few billions of queries on App Engine for SnapEngage. And we use a fair amount of instances. At peak time, we have a few dozens of instances running for serving our queries.
All right, that's significant. And so can you tell us what a typical query landing on your application looks like so that we understand what's going on?
Yes, so you were seeing earlier this chat window, and to do this display, we have to figure out, are someone in the company able to answer the chat if the user decides to chat. So the typical RPC we do on every customer web page like this one is to first bring in the App Engine memory context the configuration of the chat team. So a lot of configuration details, including what is the agent list for this team, what are the different tiers of agent, what are the rules for assigning agents. Once we have that, we need to bring also in memory what is the status of each agent. Are they online, paused, offline? How many chat does each of them is already handling, such that we know how to best prioritize and route the chat to the right person.
So you have first a batch of requests to the Datastore, sometimes backed by Memcache so as to optimize them to get the status of your agents, and then you run a CPU-intensive computing algorithm that comes up with the best agent to answer this query.
Exactly, yeah.
So let's see how your cost breakdown looks like. And indeed, it seems that the CPU is the most expensive part of your App Engine cost. So what are you doing to keep that under control?
So the first thing that comes in mind, of course, is to optimize your code. If you run algorithms which are inefficient, you're going to use more CPU for that. Something else you should do if your team has skills on different languages, you should pick a language that is also efficient at runtime. Typically, if you go with an interpreted language, it will take more resources at runtime than if you take a compiled language.
And so what language are you using?
We're using Java, which, as I think your reader knows, it's a compiled to bytecode, so it's not exactly running on the CPU or virtual CPU of the machine. There is a JVM in between, but it's fairly efficient.
So it's certainly more efficient than an interpreted language like Python. But you have another option on App Engine, which is Go, which is completely compiled. So with that, probably you would get almost an order, well, almost a factor of 2 of CPU saving compared to Java. But you haven't tried Go.
We haven't, but I think you should. That would be for the most important services, something we should do. Let me just interject something here. Now, with App Engine supporting modules, in theory, we should be able to have some part of the application using the same data store, same Memcache, but running a different language. That's something we're planning to experiment with in the future.
So, indeed, modules have been introduced recently, and they allow you to split your application into different modules, but those modules have their own version, their own language. However, it's still the same application, so they hit the same data store. So that is a good idea, actually, to experiment with one separate functionality written in a different language and to see what the impact of that on the CPU cost is.
Something else I would like to mention is, like most cloud platforms, you can pre-reserve some number of instances that you're going to use this week. So once your application reach a level of usage, which is getting more than basic, you can kind of look at what is the history for the past few weeks, decide that you're going to use at least that many instances, and tell the App Engine dashboard that I want to reserve that many instances. You don't have to schedule them over time, just saying for this week, I will use at least this level. What you gain is instead of paying I think 8 cents per hour, you're going to pay 5 cents per hour for these reserved instances, which is a significant saving.
Okay, so it's almost half price.
Yes.
All right, let's go back to the list. So the second most expensive item here are data store reads. Again, can you tell us what you can do with that?
Yes, so reading to data store is expensive, and also it's not the fastest operation you can do. So App Engine provide on the platform a Memcache service, which Memcache it's just a key value pair in a memory on one system. So for free on the platform, you get a shared Memcache service, which let you put in there some cache content that you're going to reuse quite a bit.
But it's a cache.
It's a cache.
So at any point, it can tell you that it has forgotten the content, and you still must have it somewhere in the data store.
That's a drawback, but your code should be smart enough that if you don't find the value in Memcache, you will then hit the data store. But your hit ratio in Memcache should be sufficient for you to save maybe 1 out of 10 or more requests on the data store.
The typical difference between hitting the data store and hitting the data store through Memcache is a reduction of cost of a factor of 10.
10 is just a number I'm mentioning here. It
but
depends on your application.
Significant.
It needs to be significant, yes, yeah.
And so this shared Memcache has some capacity. It can handle some load. And when do you know that you are exceeding that?
So yeah, shared Memcache, there's no real numbers, but we can kind of feel we have about 100 megabytes of storage there. It's shared across several apps on the same app server. What happens though, if some of your neighbors on the same app server are using a lot of Memcache, you could use a constraint, your Memcache lifetime may be reduced. So when you see your cache hit rate being reduced compared to your usual, it's most likely because you are kind of hitting the limit on the shared Memcache.
So the shared Memcache is free. It's normal that it has some limits. What can you do to use more Memcache if that's what your application needs?
Yeah, so an application like SnapEngage having quite heavy traffic, we are making good use of what Google calls a dedicated Memcache. So instead of having about 100 megabytes of storage, you rent instances of 1 gigabyte, and I think the instance is rated for up to 10,000 operations per second.
Okay, so that's quite significant. A gigabyte of data and 10,000 operations per second, you can handle a lot of load with that.
Definitely, and you can get several of these 1 gigabyte instances if you need even more operations per second. So it's not something typical for a small startup product, but once you see that the expiration of your content is being pressured, then that's where you can activate that. Cost-wise, it's not expensive. What you get, it's I believe $80 per month per 1 gigabyte instances.
All right, let's get back to this list. So next are Datastore writes. Those you told me are even more expensive and even slower. Mm-hmm. So again, what can you do to help there?
So the one thing you need to keep in mind is every time you persist an entity in the data store, you not only persist every attribute of this entity, like every field, but you also ask App Engine to create an index for each of these attributes. Like typically if you have a user, you have the name of the person, the email address, maybe a phone number. Persisting that will not have 3 writes, but will have 6 writes for each indexes as well. On top of that, if you need composite indexes, like if you need to be able to do queries to find people on phone number, on email address, I'm not sure what you would do that, but you have to define an additional index in your object definition. That will be also on write, another write operation.
So there is a write amplification effect that when you write one entity, every property in that entity that is indexed produces an additional write, and also every pair of properties that is indexed in a composite index that also produces an additional write.
Yes. So
all right. So you have to be very careful with that.
You have to be careful and keep that in mind, and you have a way through some properties and your definition of object to tell App Engine, please do not create an index for this attribute. For example, the name of the person may not be something you search on, so you just say make this attribute not indexed, and that way you can save significantly the number of write operations.
But that will prevent you from ever querying by that property.
Yes, that's correct, Martin. Yeah.
All right, but then, that's what you.
It's a trade-off. You have to always decide cost versus flexibility.
And the last item on this list here is bandwidth. So it doesn't seem to be that significant in your case, but you told me that you optimized it quite well. What did you do? What did you do to achieve this low number?
Several things here as well. On App Engine for Java, for example, you are hosted on a servlet container, so you have complete access to the HTTP serving headers. There are headers specific for caching instruction, telling the browser to keep your content for a certain amount of time. So by playing with these cache control headers, you can leverage the reduction of heat on your application, telling the browser to reuse what they have. So, yeah.
Right. And also, well, of course, that's the basics, but you should be careful of the resources that you use, images, JavaScript resources, and so on, the static resources.
Right. Something else I can mention here as well, not applicable for everybody, but since we are using Java for our backend, our team is very familiar with Java, and we also use Java to create our JavaScript through the GUID framework. So by doing that, it offers a lot of flexibility for testing, debugging, but also we rely on the GUID compiler to create highly optimized JavaScript code for each target. So we won't serve the same JavaScript to a Firefox user compared to a Chrome user, which means we serve the smallest possible amount of data to each of our customers.
All right, thank you, Jérôme. And there is one more point that I would like to touch upon. It's you told me that you have started using App Engine before it even had a name. Can you tell us a bit more about that?
Yeah, back I think it was very early 2008. I was contracting for Google for some gadget ads project, building these very smart ads which show content contextual to what the person search, where they are located. And as part of doing this contracting, I had early access to the platform, Python only at the time, very limited to all the functionalities. but it allowed me to see the value of having a system that scales by itself. As you can imagine, these ad campaigns spike very quickly when the ad campaign is launched, and then scale down quickly as well when the ad campaign is turned down. So the value proposition of App Engine to auto scale and just pay for what you use, it's huge in this situation.
And so that was back in
2008, early 2008.
2008. All right. So you have been an App Engine expert since 2008.
Yeah.
Well, that's impressive.
Thank you, Martin. The thing is, when we decided to launch SnapEngage in summer 2009, so one big year later, we were already convinced that the platform was what we wanted to do with a small team to have the capacity to grow quickly. Let me mention something else here, since a bit more time. Typically, when you host your application on an instance-based platform, and you have to, kind of provision your instances yourself, you will grow by chunk. If you see your traffic is growing, you will have to get a new cluster of instances with all this traffic. Scaling down is difficult at night. When your traffic goes down, you typically don't turn off instances because it's a lot of work to do that. With App Engine, your growth will be linear because you pay for what you use. The platform will add instances when needed. When the traffic slows down at night, they will take down instances and you won't be charged. So it's a huge difference in the paradigm compared to traditional hosting.
All right. Thank you very much, Jérôme. Thank you for being with us here at Root Access Berlin. And we'll be seeing you in the next episode of Root Access Berlin. Thank you.
Thank you, Martin. Thank you for having me.